Welcome. In this video we will go through the latest developments for durability domain in ANSYS and Meta 2025.2. Let's start with the enhancements in ANSYS. In the assembly, with the newly introduced seamlines control points you can define and edit on or off segments to create intermittent welding and to uniformly control step length in areas of curvature on seam welds. It is also possible to project existing model nodes for the creation of the control points. Let's move to ANSYS to see the new feature. Open the Connection Manager. Right-click on the seam line and press Edit Control Points. Now, on the seam line, by pressing left-click we can define control points. We can also define a control point by selecting a node. With this way the node is projecting on the seam line. Press the Tab key and left-click on the seam line to define the on and off segments, which are visualized with green and red color respectively. Press middle-click to complete the definition of the control points. By realizing the connection, we can see that the FE representation has been created only on the on segments. Additionally, in the seam lines, it is now possible to create two symmetric rows of weld root shell elements for Y-joint shell and overlap shell FE representation types. Moving on, in the cross-sections tool, the neutral axis is now drawn in all stress result view modes and is positioned taking into account the axial force. A new fringe bar widget is now introduced that allows the specification of the number of colors used to draw the results. Additionally, the status of cross-sections ribbon tab buttons can now be saved in GUI settings. Enable the visibility of the forces and moments. Create a new cross-section. Switch the display of the stresses to the cross-sections coordinate system, and the position of the loads to section. Define the loads. Enable also the visibility of the neutral axis. The neutral axis is now drawn in all results view modes, geometry, von Mises, etc. Furthermore, in the fringe bar we can now select the number of colors for the results visualization. The orientation vector function has been enhanced with a new option to align beams coordinate system normal to shells or faces. From the Elements Visibility button, enable the Line Elements Cross-Section option for better visualization of the beams. We would like to orient the third axis of the coordinate system of the beams, according to the normal vector of the panel. In the database browser, right-click on the Beam Taper Elements, Utility Orientation Vector. Press Ctrl and A keys to select all the beams of the model, and middle-click to confirm. In the window that opens, select Vector, Third Axis and Normal to. Use the angle selection to select all the elements of the panel. Press middle-click to confirm. As we can see, the third axis of the coordinate system of the beams has been oriented according to the normal vector of the panel. In the Results Mapper, the nodal forces from CSV file are now mapped on solids, ensuring equal resultant force between source and target. In the Solver files format, the MetaDB result files are now supported, and a new option to select specific PIDs as source is now available. After pressing Scan Solver File, press Source PIDs and keep enabled only the properties where the results should be mapped. Close the List of Properties window and apply the Results Mapper. As we can see through the deload list, the results have been mapped only on the selected PID. In oil canning, new functionality is now available to improve the user experience. With this new functionality, target points can now be generated based on raster projection, or by loading them from a CSV file. Additionally, template-driven definition of the contact, step and boundary conditions can be performed. Go to Oil Canning Settings. Select an impactor file. Press Merge. Select the impactor set, the impact area set, and the local coordinate system by pressing $? in the corresponding fields. Select the impact axis. Define the output directory. Press OK to close the settings. Go to Static Linear Candidate Points. As you can see, a new wizard is now available for the target points generation and the load case setup. Firstly, the target points can be generated by projecting a raster on the impact area or by loading them from a CSV file. In this demonstration we will use the project raster method. Select the 4 curves that define the area by pressing $? in the field. Insert length X and length Y. Select projection axis and press Generate. In the preview, select or deselect target points and press middle click to confirm. Additionally, there are options to create target points manually by selecting nodes, add target points from the current database or remove some from the list, and an option to move a target point to another position. Press Next to continue with the creation of the contact between the impactor and the impact area. Select a contact template. In the main and secondary surfaces, as we can see, the set IDs have been automatically retrieved from the impactor and impact area settings. Press Create. Press Next to continue with the creation of the steps. Select a step file. Press Create and then Next to continue with the creation of the boundary conditions. The impactor loading can be defined using a concentrated load or an enforced displacement. In this demonstration we will use the concentrated load. Select a node to apply the load by pressing $? Select the reference node of the impactor and middle click to confirm. Insert the magnitude and select the degree of freedom where the load will be applied. Press Create. A C load has been created in the defined degree of freedom for the loading, and one for the unloading step. Additionally, fixed boundary has been created for the rest of the degrees of freedom of the node. Press Finish to perform the positioning on the selected target points, and the output of the solver files for the linear static analysis. After submitting the jobs to Abaqus Solver to generate the ODB files, continue with the definition of the critical points to perform the nonlinear static analysis. Go to Static Nonlinear Critical Points. Define the displacement limit value and press the Auto button to identify the critical points from the ODB files. In the preview, select or deselect target points and press middle click to confirm. Similarly with the generation of the target points functionality, there are the options Manual, Add Remove, and Move, for better handling of the defined target points. Press OK to perform the positioning on those target points, and the output of the solver files for the nonlinear static analysis. During this procedure, also the history output requests are defined, and the NLGOM parameter is enabled in every step of the current step manager. After submitting the jobs to Abaqus Solver to generate the ODB files, continue with the creation of the report. Go to Oil Canning Report. Define the displacement and the force and press OK to launch Meta. In the new version, the report has been enhanced with the unloading state displacement results, if an unloading state exists. Additionally, the results are now presented for each target point individually. In Abaqus module, the Load Case Assistant has undergone significant improvements in data management, making it easier and more intuitive to organize steps and load case entities, greatly enhancing the overall user experience. Load case entity types can now be grouped at a deeper level, enabling better handling of large numbers of entities. Vertical column headers and step separators have been introduced, for a more practical and organized view. Step columns can now be easily shown or hidden using the dedicated Show Hide Columns icon. A new context menu allows activating or deactivating entities across multiple steps, streamlining user actions. Background colors now clearly indicate whether an entity is active or inactive within a step. The first improvement is the entity grouping. As we can see, in the boundary conditions we have different groups for the boundaries and the C loads. Also, in the interactions we have different groups for each contact type. Then, the column header's orientation can be switched from horizontal to vertical, by pressing right-click on a header orientation vertical. Through the Show Hide button you can make visible any step or hide it. By pressing right-click on an entity's checkbox, there are options to activate and propagate. In order to activate this entity for the rest of the steps, activate all. In order to activate it in every step, deactivate and propagate and deactivate all. By pressing Activate and Propagate on the first step, this entity is activated in every step except the initial state. Finally, as we can see, green or red colors indicate whether an entity is applied or not in each step. Moving on, A new function under Abaqus Materials List to suppress specific subkeyword is now introduced. The suppressed keywords appear with a strikeout on their labels within Material Card. During output, a relative message is also printed in ANSA info window about the suppressed keywords. Open the materials list, and double-click on a material to open its card. As we can see, here we have a plastic definition. Press right-click on the list and then suppress keywords. In the window that opens, we have all the keywords of the materials. Go to the plastic keyword and enable the suppress checkbox. Now we can see in the material card that the plastic keyword label has been marked with a strikeout. Therefore, during output, the plastic definition will not be written in the solver file. Go to File, Output, Abaqus to output the solver file. As we can see in the info window, a warning message is displayed that one plastic keywords were not output, suppressed by user settings. When it comes to user productivity, the encryption and decryption of Abaqus include files are now supported. This functionality is available through the context menu of the Includes list. From the Includes list, select an Include to encrypt. Press right-click Actions Encryption Encrypt. Set the encryption executable path and the password. Press OK to perform the encryption. In the current directory, a new file has been created with the encrypted include. Open the card of the non-encrypted include and set output No. Go to File, Output, Abaqus to output the solver file. As we can see in the solver file, the non-encrypted include has not been written, and the encrypted include has been written along with its password. To decrypt an include, press right-click Actions Encryption Decrypt. In the Encryption Options window, press OK to perform the decryption. As we can see in the Includes list, a new decrypted include has been created. That's all for ANSA. Let's move now to Meta. Bolt Assessment now supports bolt diameter and class libraries. Users can define their available bolts, perform analyses and what-if studies using them. Definitions can be saved and imported using a CSV file format. Additionally, the bolt assessment now incorporates a new algorithm that evaluates axial force, shear force, bending moment, and torsion along the entire bolt length. These quantities are calculated at all cross-sections, based on the bolt mesh and for all states. Bolt failure is assessed using the worst-case combination observed over the entire time event. This concludes the presentation of the latest developments for durability domain in ANSA and Meta 2025.2. Thank you for watching.